My name is Sarah Wolf. I'm the clean energy advocate for VPIRG. I'm going to give a little bit of history about why VPIRG is here today, and then introduce our consultant, Mr. Scott Bodwell of Bodwell Acoustics, to detail our proposal. VPIRG, as an advocacy organization that really strives to examine the evidence and then represent the broadest possible public interest, looked at this proposal from a fact-based perspective to develop and propose a standard we felt was both enforceable and predictable, that worked for all stakeholders, whether they were potential project neighbors, developers, or all Vermonters, as we move forward on wind development as a state to meet our goals of 90% renewable energy by 2050. We've been working with Mr. Bodwell in drafting this proposal and our comments. He is an accomplished acoustic engineer with decades of experience. He's worked with the Maine Public Utilities Commission, several wind developers, as well as a group representing landowners who had complaints about noise from wind turbines. We reviewed a number of different standards and talked to a number of different acoustic engineers and decided to engage with Mr. Bodwell because we felt his breadth of experience would add an important voice to this proceeding. And we also felt that his work in Maine on a standard that has been proven, that has gone through many of the same issues that we're discussing here today, and that in fact has a very a similar relevance to some of the characteristics in Vermont, that would be a really helpful perspective to bring here to the table. Before he begins, I do want to acknowledge the board's difficult position in weighing this complex issue, and I appreciate the opportunity that you've given for all of us to discuss our proposals and hopefully answer any questions that you have. We acknowledge that one clear goal of this proceeding is to address some of the existing issues that have come up with existing CPGs that have been brought up by other stakeholders that we've noted here as well. One of these being the lack of a consistent protocol for both pre-construction modeling and post-construction operations testing, as well as the interior standard, which creates difficulty both isolating the wind turbine sound and is very disruptive to project neighbors. Turbine shutdowns and the measurement of ambient noise, which we think are imprecise methods for gathering sound data, and the current complaint process, which is costly and confusing. Partly because of these issues, we note that there is a lack of trust by some parties in the existing standards and their enforceability. And we recognize that particularly the lack of consistent protocol for the modeling and the post-construction operations testing are opportunities for improvement to make the standard more enforceable and predictable and make it work for all stakeholders. So we really focused on that in drafting our proposal. And I will now turn it over to Mr. Bodwell to discuss that proposal.
Thank you. Council Head, good morning. Thank you for the opportunity to provide proposals for the wind turbine noise rules on behalf of VPIRG for their stated goals for responsible renewable energy. My position in undertaking this effort was to provide fully supported by direct experience recommendations for best available methodologies for some of the things that the department had presented about. The two most important elements to this, I believe, are the sound modeling of wind projects based on recognized international standard to quantify turbine sound power levels. And the second, that dovetails with that quite closely, is proven methodologies for operations, sound testing, wind turbine sound testing, to validate model predictions and evaluate compliance. Whatever this limits and quantifiable limits that you decide on, to me these are the basis for making it work. And by having effective protocols in both of these areas, I think is going to resolve the large majority of the questions and issues that you're dealing with based on the histories here in Vermont. With these, and it would also benefit all the stakeholders. With these methodologies in place, then you would be in a position to establish sound limits based on scientific assessments of community noise exposure by widely recognized organizations. For example, World Health Organization, EPA, the American National Standards Institute, and ISO, some of the standards that have been referenced in some of the submittals. Most important in doing this is that the limits be based on the sound metrics and time frames that are provided in these guidelines. And They must be fully and understood and accurately applied. So I'm going to describe each of these elements. We're going to start with the modeling. A lot of the points that I'm making here are similar to what Air Acoustics, Mr. I forget to pronounce his last name, but he did a nice job. What is it?
Ashtiani.
Ashtiani.
It's okay.
Sorry. I had it earlier. And it's terrain-based, three-dimensional is what's available. It's all based on topographic mapping, and pretty much most of what he talked about. But I got up and asked about, that these things be very well specified what the assumptions should be. And so that all of the projects do this in the same way, so that you have a baseline for that. I would not leave too much up to the discretion of the projects. If they want to make things more conservative, they certainly can do so. But I would encourage you to do most of the things that Mr. Asianti talked about, and that would be turbines at full rated sound output, no attenuation for trees or foliage that can come and go, and ground absorption that includes acoustically reflective surfaces. For example, modeling water bodies as a totally acoustic reflective surface. Also, the calculation should be with all receptors downwind of all turbines, which is not a physical possibility, but that gives you some factor of safety in actual operations. One thing that I would add, and that I've done on my projects in Maine, I don't know if Maine requires it, but we've also, to protect the project developer and to put the turbine manufacturer in a position of responsibility, we require that the turbine manufacturer provide a sound warranty. We guarantee, as the turbine manufacturer, that our turbines will not exceed these levels. And those are under conditions that are stated by the IEC standard for determining sound power levels of wind turbines. And within that, they also express what the uncertainty that goes with that warranty is. And when you do your modeling, you include not only their warranted sound power, but the uncertainty that's included. You don't leave it out and say, well, plus or minus 2, you keep the 2 in there. And there should also be another adjustment to the model, for the sound model accuracy. Like the state of Maine allows 0 to 2 dBA depending on siting, but there should be some basis and some specified modeling uncertainty. There are 2 types. First, you have the warranted sound power. You've got the turbine manufacturer's uncertainty, and then you've got the model uncertainty. And that gives you conservative factors for the modeling. And all of this should go in at the beginning, the planning phases for permitting, to demonstrate compliance for project approval. The reason I believe that all of this stuff is important to specify, up front as regulating this, is if you leave this up to the discretion of developers, some developers that may have people that haven't had the experience to know how important these factors are, if you get turbines that are improperly sited to begin with, it becomes very difficult to mitigate. It's a lot easier to mitigate a fixed power plant as opposed to a wind turbine that's spinning in the air. So the idea being that you'll avoid a lot of the problems that you may have seen in the past. As far as the testing protocol, I think you've seen some similar slides to this. This is a windrose that shows a predominant wind direction. What you want to do, very similar to what Air Acoustics is recommending, is monitor locations with the highest potential to exceed the limits. You want to be, I think, predominantly downwind or in crosswind. I would go to crosswind, but I wouldn't think I'd go much past that. And you want to put this under rigorous protocol conditions. One of the things that I would, and that aligns pretty closely to what they had recommended. One of the things that I would also recommend is that a project notifies the department in advance of any intent conduct sound measurements. So you either provide the prior notification that you're going to be conducting sound measurements, and at that point, that project is obligated to provide all of the data that's associated with those measurements. Turbine operations data, turbine power outputs, and all the sound level data. Because what the Maine Department of Environmental Protection figured out is that some projects were hand-picking the data that met the criteria and maybe leaving some out that maybe didn't look so good. So I think that's an important element, is that prior to conducting any operations testing, that the department be notified of those dates. My approach has been to try to pick test periods when these protocol conditions, that I'll get to it in a little bit, are likely to be met. So I don't tend to do long-term monitoring projects. We track power forecasts, we track wind forecasts, and so forth, and we get power forecasts from the wind project. We consult with meteorologists, including National Weather Service, to try to pick the conditions that we need. When we have that, what we do is tend to do the testing in 1 or 2 overnight periods as opposed to long-term.
I just want you to know you've already used up 10 minutes. Do you have much further to go in the presentation?
Oh, I thought we got some time from RSG.
Yeah, RSG
Oh.
had ceded to their time to us and the
I could move it along a little bit, but I thought I had more
All right,
time.
okay. Keep going.
Sorry, I should have clarified at the beginning.
Next slide, please. And I'm trying to just point out really what's in addition to what was proposed by your department that I think might be worth thinking about, so I'm not going.
Not by us, by the Department of Public Service.
We're separate.
Yeah, the consultants that you,
It's
yeah.
We didn't
not us.
Department of Public Service.
No, I understand, yeah. Don't they work?
No,
No.
they have nothing to do with us.
Oh,
That's
okay.
the-
It's a little different than Maine, okay.
Yes,
all
it's,
right.
they're separate.
Okay, but anyway, this outlines the conditions that I'm advocating for. What you see here is this is a diagram shows a ridge top. The wind turbine is probably oversized here, but what we're trying to do is get the conditions where the wind is strong on the turbines in a stable atmosphere, so that there's less wind as you go down. So there would also be less wind over here. And so what we want is the turbines at full sound output, and we're saying full sound output, not within a couple decibels, but actual full sound output. And we want these surface winds measured at 10 meters. And we are opposed to measuring at microphone height because there's too much interference with ground conditions. We want these, and this follows the main protocol pretty closely. We want the sound level, the wind speeds measured at 10 meters to be right around 6 miles an hour or less. This usually happens during a stable atmospheric conditions. And what this allows you to do, and I know there's been a lot of talk about the procedures, turbines on, turbines off, the wind speeds and so forth. What this will allow you to do is take direct measurements with turbines running without having to shut them off, without having to do ambient adjustments. The only times that this won't work is if this receptor point here is located close to another source like a highway or something, and that probably wouldn't be a location that I would recommend. So the protocol that we're recommending is going to simplify this for everybody. It's going to remove the adjustments and the inaccuracies that are associated with the adjustments for ambience, not going to require you to shut turbines down and so forth. We've been using this for a while now in Maine, and it works. It simplifies the data, it makes the data set cleaner. Next slide, please. These are 2 charts that try to show the difference between, this would be protocol conditions, these are sound levels right here. This is the highest 10%, the lowest 90%, in the middle is this equivalent sound level. You can see that with these protocol conditions, these sound levels are pretty stable. This is turbine power up here. When we have variable conditions, you got surface winds and everything else, these track the turbines, and this, even if you subtracted the ambient out of this, you would still introduce all kinds of inaccuracies in trying to determine what turbine sound levels are. So our proposal is that you can find these conditions. We've done it on several projects. Gives you a clean data set, and it eliminates a lot of sources of error. I just probably went through this, so we can bounce around. The next thing I wanted to talk about was establishing limits in the methods or basis. several proposals that proposed limits that were reportedly based on independent studies, but they really didn't use the same metrics that were in those studies. We agree that the limits should be based on independent, factual community noise studies. These should be studies of long-term sound exposure, which have been used, but the metrics need to represent what the studies show, and that's what hasn't happened yet. The proposed limit that we have does that. It's a 10-minute exterior sound limit of 45 dBA, and we've done an analysis to show, next slide please, based on actual operations from a project in Maine, the actual turbine output levels for a year, based on testing under these protocol conditions. The model estimates were 45. The highest sound level we measured was 41, and this shows the distribution based on annual operations of that project. It's a little hard to read, but that's the 41. A certain percent of the time they were at full sound power, and then as you lower sound power, you lower sound levels, so that the annual nighttime sound level for this, with a model estimate of 45, was actually 39. And this, for 24 hours a day, this meets the WHO nighttime limit, even though it's 24 hours a day. It also meets the EPA indoor sound limit of 45 LDN. So the actual long-term exposure based on real turbine data, real measurements and so forth, would yield these results in line with the proposal for the proposed limits. Just want to talk about setbacks real briefly, if I still have time. We good? Okay. This graphic here, these are wind turbines. This is the same project from where the table that the graph you just saw came from. Each of these, this is a model of sound contours you produce out of a sound model. Each of these bands, these colored bands, are 5 decibels, range 5 decibels. There's a key up here. I can't read that, but I think the red goes from 40 to 45. So this is going to go 40 to 35 right through here. So that the limit that we're targeting is 45 right here. And I wanted to show the difference between how far you'd have to be from turbines if you're perpendicular to the turbine string to reach 45, which in this case is 3,000 feet, okay, versus if you're at the end of the turbine string to reach 45, which is half the distance at 1,500 feet. So if you had a setback of 2,500 feet, it's going to be more than you need down here, but it's going to be less than you need down here. So the message is that setbacks do not correlate with sound levels. And in thinking about setbacks, one setback option that I don't think I have heard would maybe to have a setback from the residents of where the limit should apply, as opposed to a setback from turbines, or a setback from residents where turbines could be built. So if you had a limit that applied, within so many feet of a dwelling, then you could establish that limit to be, if it's so many feet from the dwelling, the setback could be from the dwelling as opposed to the turbine. It might be an option you might want to consider. Next slide, please. So to wrap it up, we agree on the proven sound modeling. We think it needs to be very specific, and we need to have very specific protocol conditions that will eliminate a lot of the confusion, a lot of the adjustments to the data. I do believe that you should take the measurements as reported, not try to make adjustments for uncertainties. That gets you in a whole different area of subjective reasoning that I don't think you need. It introduces a level of conservatism in your measurements, and the protocol that we're proposing enables you to do this testing and get direct sound data from turbines without any adjustments for ambient. We also stress that the limits should be based on the metrics, on the appropriate use of the studies and the metrics from these independent studies. And those are long-term exposure studies, and they do use equivalent sound levels, and they usually put those out for a year, and that's what we've done in that analysis of Stetson too. And I think with these, this will benefit all the stakeholders, and it will meet the goals, enforceability, predictability, and reliability of the data in the program. So that's what I have.
Thank you. Could you tell us a little bit about your background?
Sure.
Who you work for or have worked for in the past?
Yeah, I have my own consulting group, Bodwell and Bioacoustics. I founded it in 2009. Before that, I worked for another consulting firm. I've been working on acoustical sound studies in Maine since 1987. I've done just about anybody that makes noise in Maine, I usually show up. I've done more sound analysis and testing of projects in Maine, and there are a lot of projects in Maine than anyone else. I've worked with the Department of Environmental Protection beginning with the Mars Hill Wind Project.
That's in Maine.
That's in Aroostook County, Maine, and I worked with the Maine Department of Environmental Protection's sound consultant at the time named Warren Brown. I don't know if you've heard of him, NRAP Consulting. But he essentially came up with this protocol working with a meteorologist at the University of Maine. And when he proposed this protocol and we started using it, we found it to be extremely effective to provide extremely accurate data, to get you when you need to be there, and to provide you a very clean data set. So it's the history from starting this and going through trying to figure out how to do all this. There really isn't a national or international standard on how to measure sound levels from wind turbines at community locations. But I think this protocol, from all the ones that I've looked at, overseas and all across North America and so forth, really does provide the best and most accurate data. It's fairly easy to do, and it removes a lot of the uncertainty in the test results. So I'd encourage you to take a really hard look at this. It dovetails nicely with what the department has recommended through their consultants. It just takes it a little bit further and maybe a little bit more precise in some areas.
Can I just have a point of clarification on that question Chairman Volz asked? You said Maine Department of Environmental Protection, but I thought Ms. Wolf also mentioned the Maine PUC.
Yes, I've done work for the Maine PUC Ombudsman, and there was a huge electrical infrastructure upgrade in Maine called the Maine Power Reliability Project. And I worked with the Ombudsman to assist affected landowners that were having noise problems with some new substations that were built as part of that project. There was compliance testing done for those substations by several large national consulting firms, denying that there was any problems with any of those, but the complaints kept coming in. So the Ombudsman, on behalf of the PUC, retained me to investigate, and what we found was there were some major sound excursions coming out of these new auto transformers. They're producing sound levels that were well above the performance guidelines, the specifications, and the limits that were applied. But they were so random and so difficult to capture that the testing that was done said that wasn't true, that they said it was the wind in the trees and so forth. So we were able to do testing. We were able to find these excursions and document them. We met with the Central Maine Power Company, the PUC, and they have discovered that the cause of this was actually ground-induced current, DC volt, that was entering the transformer from the neutral to ground, and were actually caused by sun activity and up and down.
That was good. Thank you.
Okay. Interesting project, still ongoing.
Have you done work for wind project developers?
I have done work for many wind projects in Maine. I could provide a list, but
No, I just want to get a general sense.
I have First Wind. It's just transferred to Sun Edison, and now it's projects by Nevada's, University of Maine. We're working on the offshore wind. I can't think of the client's name right now. EDP Renewables is another, and I'm also have a client, a friend, Fox Island Wind Neighbors, that are affected by the Lionel Haven Wind Project, and we have done measurements with them to document noise violation, and we're helping them get that resolved with the state. So I've tried to remain independent and work for parties. I've done peer reviews and so forth.
like to put a question to you, gentlemen. Since you're from Maine, you must be familiar with the Freedom Maine wind ordinance.
I'm familiar with the Freedom, I think it was Beaver Ridge wind project, and I know that they then, that was a project that was a noise problem. It wasn't properly cited, and I think that the noise ordinance that you're talking about may have been a result of that. I haven't been involved with that project. I just know that it was
So that
first
wind
built, it
ordinance,
was
that
poorly
wind ordinance
cited.
has a setback distance based on the relationship of the height of the tower. They specify 13 times the height of the tower. So for a 500-foot tower, that would be a 6,500-foot setback. Do you think that's unrealistic or inappropriate?
I don't agree that the setback is a good tool to regulate wind turbine sound. I think what I've proposed here in the modeling and the testing, I've demonstrated that how a setback can be not restrictive enough in this case, or overly restrictive in this case, and I just don't, it doesn't mix. It just, the setbacks don't correlate to sound level, so I don't think the setback is a good tool to regulate noise.
Yes.
Eddie Duncan, RSG. As I understood it, for compliance monitoring, VPIRG would be proposing a very specific set of meteorological conditions and would not back out ambient sound levels from that, similar to how the state of Maine uses. And if that is the case, in the state of Maine, in our work in the state of Maine, we've actually found it quite difficult to find when those conditions would actually occur. And it's also possible for those conditions to, we've found that it's possible for those conditions to occur and for there to be elevated ambient sound levels because you have high winds aloft, and if you have a ridge line in a forest on that ridge line, then that forest on that ridge line can also produce elevated background sound levels. And so I'm wondering if you could speak to those issues and also how long you tend to monitor or how often you have to go out to try and get these conditions that you propose.
Sure, that's a really good question. And first I want to clarify that in every case for each project that I've done compliance measurements for, which has, probably been 8 or 10 in Maine, we've been able to find the conditions that we needed. In fact, on one project we tried to, before we figured out the best way to do this, we tried to do the shutdown process and then measure ambient during the shutdowns. And what we found was that the conditions between when the turbines were operating and when the shutdowns changed so much, it was an unreliable method. So my first choice would be to try to find these conditions. It's tricky. You have to track a lot of forecasts. We put our stuff out in the field in advance so that we don't decide when we're going to go until we get the forecast the day before, and we say, okay, now we're ready to go, and we do one last forecast check in the morning before we go. So we have to be close and very reactive to it, and sometimes it can take 4 to 6 weeks to get the right conditions. The key is that to be out there when you have the right conditions. If you do the best you can and you still can't do it, I'm not saying that we should eliminate the ability to do the ambient shutdowns, but I do think that introduces a source of error that if you could do it without that, you have a better data set. But if you are going to do it, then the proposals that you have for that look to be good. But I just don't think that's something that you should have to do, and we found that it's not necessary. We're able to isolate wind turbine noise under this protocol, but it takes a lot of tracking of forecast information and working with the project and so forth. So it's not easy, but if you can kind of figure out and use the forecast effectively, and talk to the meteorologist, staff meteorologist, the National Weather Service and so forth. They'll check models for you on the phone and all this stuff. And so you can make it. We've been able to bat about 100% on doing it.
Other questions?
Can I do one brief follow-up?
Sure.
If three independent firms who never had any contact with each other did the initial modeling and then did the monitoring, would they all come in with exactly the same result?
For which part?
The whole shooting?
Well, if the modeling parameters are specified in sufficient detail, all the assumptions and settings that you need to use, the modeling is based on the warranted sound power and with the warranted uncertainty and the same accuracy for the model, those numbers should come out exactly the same.
And then the monitoring?
Monitoring is going to depend on site conditions, the aeroacoustics fellow said that, temperature, humidity, wind gradients, wind shear, I mean, these are variables.
There is wiggle room, in other words.
Well, the idea is that the modeling is conservative enough that it's going to cover the worst predictable case for those conditions. So we found in the testing, that we can be, right at or near, and there's a little bit of ambient sound in there, but we're pretty close, as long as you can demonstrate compliance. But we've had, the same modeling, the same basis, warranty, and so forth. We've had testing that's been a couple decibels below the limit, but we've also had testing that's been 5 or 6 decibels below the limit. The testing here, the highest number that we had was actually 4 decibels below our sound model prediction. That was based on 2 overnight periods of testing under those protocol conditions.
Back of the room.
How many measurements?
Please identify yourself, please.
My name is Steve Ambrose, and I know Scott Bodwell, and I deal in noise, but how many measurements did you chart like that for Stetson? Or is that just for one unique location?
2 locations.
Similar results?
Yeah, very similar results. This was actually the worst case location. I did everything in the worst, highest level, distribution and so forth. That's the highest 10-minute, and I would like 10-minute as an interval for this protocol. I don't know if I mentioned that, but that was the highest measured 10-minute that we had under the protocol conditions, and I think it was for 2 overnight periods. Now this was back in 2011, so if I'm making a little bit off here, it was a long time ago. So from there, we assumed that was going to be for the full turbine output. Every hour we got turbine operating data, we plugged it in, adjustments to the model, and then calculated what the sound levels were going to be for however many hours there are in a year, every hour, and that's the distribution that we come out with, based on the highest measured sound level for any one 10
Is
minutes.
that measured or predicted?
It's both.
No, one or the other.
No, it's actually both. The highest sound level was measured, okay, at full rated output. The rest of them are based on the power curve, adjusting that measured sound level. So the one that shows at the top, anytime that the nearest turbines were at or above full rated power, that's what that one is. As you drop down and power levels out of the turbines go down, then you see the distribution of the sound level. So it's based on actual measurements at full rated sound, the highest we got, and then the model to then adjust based on the power curve based on that. So it is actually both.
Other questions? Yes, Mr. Lewis.
You mentioned that your preference is not for doing turbine shutdowns because of the possibility that conditions will change over the course of the amount of time it takes to do a shutdown. Do you find that the bidding approach that Mr. Ashtiani put forward mitigates that concern, or do you have, I guess that's my question.
Yeah, I think it's an effective way to do it. I think if you can get these protocol conditions, though, you don't need to do it, And if you don't need to do it, you have a cleaner data set, you don't have adjustments. And I think Mr. Asiandi would concurred with that. I asked that question during his presentation. He says, yeah, if you could limit the surface wind speeds, and I think the key on the surface wind speeds is not microphone height. It's 10 meters and it's in a wide open area. So when that surface wind is low enough and the turbines are at full sound output, you don't need to do these other things. You don't need to shut them down. You don't need to measure the ambience. You have a clean data set, direct. It removes a lot of the uncertainty and gives you the best data that you can get. Now, that's not always possible. So, you know, if there's a situation where you just can't get those conditions, yeah, then you go to the turbine shutdown method, and the bin method that he suggested would be the best way to do that, I believe.
Go ahead. Yeah, sir, it's my understanding. Yeah, the only thing I'd say is, yeah, I definitely agree if the intention is to show compliance, and you can show compliance without removing the ambient sound, then doing a shutdown is only going to remove more sound out of that assessment. So it is a conservative way of looking at it, and if you can show compliance, power to you, right? The only caveat, as you mentioned, is that if you have a situation where the sound level is not compliant in those conditions, you have to be able to know if it's the airplanes or if it's an ambient contributor to that. And so in I would say that shutdowns are not always absolutely required, but they're usually pretty helpful.
What we have, and I didn't go into it because I didn't want to run out of time, but the way we do that is another part of the protocol that's in the documentation that was presented. In addition to the 1 minute or 10 minute sound levels, we also believe that you need to take very short time sound levels. The state of Maine uses a period of 50 milliseconds. So that's 20 sound level measurements per second. You need to plot that, and there's capability where you can then you can see the pattern of wind turbine sound within that, and you can see the pattern of other sources within that, and you combine that with an audio record during the measurements, and there's capability where you can, if they're time-stamped integrated audio records, you can actually track the audio with a moving cursor through the sound levels, and you can pick out which sections are wind turbines and which sections are something else. And you could, as opposed to necessarily having to subtract out ambient, you could actually track out segments of your measurements that aren't wind turbines and leave what is wind turbines there. So you could do that. You could do that without shutting down wind turbines. And that's what we do. That's what we do as part of our analysis.
Thanks. I think you have a question?
Sure. In your recommendation, with respect to pre-construction sound modeling, you recommended calculating out to a distance of 1 mile. I was wondering what informed that distance. Why not more? Why not less?
That's all projects we've looked at. We've looked at some pretty big projects. That's where you get down to your limit, proposed limit. So if I suppose you could go further than that if you felt more comfortable. It's not a big deal to do the modeling out that far. The trick part that is to identify all the land uses and find the houses, and there's a lot of field work involved. And so if you had a caveat that within 1 mile you still haven't reached your limit, then you could say within 1 mile or where you reduce sound to the limit. So that's not a hard and fixed number. That was just typically what we find is sufficient.
Okay, and also, as I understand the suggestion with respect to the post-construction sound monitoring, you recommend doing that during a time of year that's favorable to sound testing after all the fall leaves have come down, but before the coldest months of the year. Why is that the proposal, and does this have to do with the earlier discussion that we had about effects of temperature and freezing and relative humidity, etc.?
The reason for those time periods is a couple. It's after cricket season, so you don't have the crickets as an issue. It's after leaf off, so that reduces your ambient sounds from wind. And what we have found for most projects, those months are the most productive in the Northeast for wind generation, so that you have the highest opportunity to have your wind turbines at full sound output. And we also have found that those are the months or time periods that you tend to have the stable atmospheric conditions more. So we've been able to achieve all of the objectives of our testing with the forecasting, but it has been during those months. So I don't know how we would do, during other months that are a little more unsettled. So the weather patterns during that time of year align nicely with the turbine production, with the ambient sounds, and with wildlife activity. So it is really sort of the ideal period. Not that you can't do that, but we've just went through a program of trying to do similar testing during June and July, and most of your best periods are in the middle of the night. The bird chorus starts around 3:45, so there goes 3 hours that is usually pretty good. And then there's just so much vegetation at your sound test sites, grass, leaves, shrubs, everything, that it's really hard sometimes to isolate wind turbines. So if you can swing it, that's the best time to go. That's the time we try to go. I haven't done a lot with the spring programs, but that's what Mr. Santi has found works very well for him. So, maybe his weather patterns are a little bit different where he's doing it.
Now he's gonna tell us, I guess.
I should add, now is a great time for us as well.
Yeah.
Basically, after the fall harvest, corn is another one. If you've got people farming that have corn, it ends up being a significant amount of ambient noise just because they get so tall. As soon as the corn's cut, our noise monitors go out, which is, it's our busiest seasons are basically from around now until it gets, too wintry to, if you get a snowfall which completely covers all your noise monitors, then that's a problem. Until, late winter, early spring, and then if you can't finish it by the early summer, then you're going to be chasing those wind conditions all summer until the fall, and dealing with things like spring peepers, and then crickets, and then leaves on the trees, and then crops. So I mean, once the season comes in, there's a lot of things to contend with, but then once the around Thanksgiving time is when you're like, okay, nobody else is going to contaminate as much, and now it's your turn. But
It can mess up your holiday season to be on standby for 2 months. That's the best way to do it. And I mean, you don't want to go out and get a batch of data that you have to sift through and figure out. It's just so much better when you get the conditions. I mean, after we do a night of testing, the next morning we show up at the operations building. We get the turbine data right there. We get our MET data right there, and we know within an hour or so whether we met the conditions. So it really is effective.
Thank you.